So lag distance. So basically this is the distance traveled by the vehicle during the total reaction time. Okay, now reaction time of the driver is a time taken from the instant the object is visible, that object is visible to the driver, to the instant the brakes are effectively applied. Okay, so that is the distance. Now if v is the, suppose v is the velocity of a vehicle, or suppose 30 km is the velocity of that vehicle, in that case if the reaction time is 2.5 second, in that case that distance covered during that time would be 30 into 2.5 seconds. So for our calculation, suppose we consider that the velocity of the vehicle is v meter per second and your reaction time is t second. So the total distance covered during that reaction time would be v into t seconds, t meters, sorry, v into t meters. Now coming to the next portion, that is braking distance. Okay, so braking distance is the distance covered during the braking operation. Now the braking distance, and for a level of road, this is obtained by equating the work done in stopping the vehicle and the kinetic energy of the vehicle. So work done means what is work? That is the force applied over there and some distance. Okay, that is the force into that distance. So if F is the maximum frictional force developed and the braking distance is L, then F into L is your work done. Now here think of this situation. Whenever that vehicle is over there, okay, it was running with a speed of v meter per second. So after that place, that brake was applied. So after this place, the deceleration of the vehicle get started. So initially here speed was v. So after the application of the brake and after uh, uh, some distance, the final speed of the vehicle would be 0. So here that kinetic energy is lost. Okay, so the kinetic energy is lost. So the total kinetic energy over that area would be half into w into v square divided by g, where w is the weight of the vehicle and v is the speed of the vehicle and g is gravitational acceleration. Okay, so how this half into w v square by g is coming out? That is because of this, because we know our kinetic energy is half mv square. So we have converted that m into m equal to w by g. We put this and we got this equation. So if we equate both these two, that is our work done with the kinetic energy, in that case FWL is WV square by 2g, or L equal to V square by 2GF. Okay, so therefore our SSD or stopping side distance is basically lag distance plus braking distance, that is Vt plus V square by 2GF. Okay, so this is our stopping side distance. So I think it is clear. So let us discuss this again. So how it is happening? So one driver is there, he sees some object, and in that case during the reaction time he decides that he needs to stop the vehicle. So during that reaction time he will travel with that desired speed. After that he will apply the brake, and after the application of the brake, that vehicle will stop over there. So there is two particular components of the stopping side distance, that is the lag distance or reaction distance and braking distance. So lag distance is calculated by multiplying the velocity or speed of the vehicle to the into the reaction time, and braking distance is calculated by equating the work done during that particular distance with the kinetic energy of the vehicle. Okay, So this is our stopping side distance calculations.